And next on, I'm welcoming Alexander. I think you're joining us from Gothenburg, from Göteborg today, right?
Yes.
Yes, great. Alexander is going to present about LCA as a step towards regenerative design, current trends in research and practice. And Alexander is from the Chalmers University of Technology in Gothenburg in Sweden. He is assistant professor working with digital tools in LCA, as well as the head of research and development of Kala, LCA company, which I suppose you are going to introduce.
Yeah, thank you very much for the introduction. And I'm mostly doing the research at Chalmers in Gothenburg, but I show some case studies from practice also based on the startup that's mostly working in Germany. I'd like to talk today about what is LCA. I mean, we already discussed a bit now and here in Pier's discussion, just a brief overview, and also why is it important in my point of view, which frameworks exist, and then most importantly, from my perspective, who can use LCA when and for what, and then what can we expect in the future with regards to this topic. So we already saw the life cycle from Pierre, but very generally speaking, life cycle assessment or life cycle perspective tries to look at the whole life cycle of a product, whether it's a material or a building, from the production over the use phase and the end of life. And there's a special phase, which we saw as module D, trying to look at benefits and loads beyond the system boundary, often reuse, recovery, or recycling potential, or also, for example, exported energy. So positive impact is often attributed to this module D. When we talk about LCA, we have different indicators to use to measure the performance of the life cycle. So it could be the energy, including the energy in the embodied energy needed for the production of material and the energy during the use phase. We can use CO2 equivalent or greenhouse gas emissions. We can also use social indicators like disability adjusted life years or economics like euro, and then often we call it life cycle costing. So there are different options. If we look at carbon emission, we already heard from Pierre how many different, in different ways we emit greenhouse gas emissions. And if we look at buildings, especially residential buildings, we saw that in the past, over a life cycle of 50 years, most of the emissions came from the operational phase, and the construction was a minor part. But over the years, the building got more energy efficient in the operation. So now in the standard building, it depends on many parameters, but we can say on average, it's like 50-50. The embodied part, so the part related to the construction and demolition of the building, and the operational part. So it's clear that if we talk about zero emission buildings, we also need to include the other 50% of the construction phase. Now, if we talk about frameworks, we already saw this different modules, and the main framework to relate to is the European standard 15970-87, which defines those life cycle modules. And as we saw, different systems refer to different modules. The aim is always to include as many as possible, but of course this is high effort, so usually simplifications are made. If we look at the case of Sweden, there has been introduction of a new law which demands so-called klimatdeklarationer, so climate declaration of buildings, and those are mandatory for all new buildings, with some exceptions for really small or military buildings in Sweden that hand in a building permit after January 1st next year. So it's really soon. And they include in the system boundaries, as far as I understood, but Pierre, correct me, that's not the case, only the envelope, so everything that parts of the building envelope, the load-bearing parts and the interior wall, but in contrast to the null CO2, HVAC systems, so everything building services are not included, and also exterior parts, for example, a terrace outside, are excluded. And if we look at this life cycle modules, only the first phase, the production and construction, is included. And also here in the transportation phase, only the transport of the material to the construction site is included, not the people that are transported there. So if we look throughout Europe, we see more and more of those national regulations or different certifications coming up, but usually with slight differences to those life cycle modules and also what kind of building elements they include. So now to my question about who can use LCA when and for what. I mean, we saw the case of we want to certify a building and in a way state the environmental loads and also maybe benefits this building has. But throughout the design phase, there are different points in time when we can use it. I mean, very in the beginning, before there has been made the design, we can use it to set baseline and targets. We just saw how this null CO2 certification does it. But also more and more project developers start setting their own climate targets for their projects. During the concept phase, usually it's architects involved in designing a building, having different massing models, comparing different construction types. The typical question, should we build in timber or concrete? How much greenhouse gas emissions does this really save? So here it's about comparing many variants really quickly. In the detailed design phase, that's what they call refined LCA. It goes more towards looking which material can we use for which type of construction and which manufacturers are there. So that's then important to look maybe at environmental product declaration, look at how the steel that I want to buy is really manufactured, for example. So it involves more engineers and contractors. The construction side, call this now this as-built LCA, meaning I want to document the environmental impact. Then it's clear I cannot change it anymore, but I have all the information, for example, to apply for a certification. And finally, in the use phase, it would be great to learn about the energy demand of the building, for example, monitor it, but also learn about the real replacement needs and times to then define better targets and baselines for the future buildings in these pre-studies. Of course, throughout the design phase, we get more information and the LCA can become more accurate, but at the same time, the optimization potential we have gets lowered. So in these early design phases, we have the highest potential for optimization. And here I'd like to show 3 small examples we did with Carla. So this was an example by a project developer. And before opening an architectural competition, the company wanted to set a target and learn about what would be possible on the specific site. So we defined simple boxes, a massing model, and then assumed different variants. So 4 main materials, the timber and construction, reinforced concrete construction, masonry, building, and a hybrid solution, different types of basements, different heating systems, different window to wall ratios, and options for PV. So in total, 325 combinations. And then we can use the tool to run over all these solutions and plot the greenhouse gas emissions we get per square meter. And then it was up to the client to set, okay, here, this is my limit value, or this is the target I want to have when I then have the architectural design competition. In the architectural design competition, the tool was also used to compare different projects. Now this is a different project. And then we later assessed the different entries to the competition and compared the greenhouse gas emissions. And here, number 1 was a timber building, which then at the end wasn't picked and had some, apparently some difficulty with fire protection, but at least this was information that was provided with other criteria in this for the jury to then take a decision in this competition. A bit more in the detailed design phase, this was a project where the architects had included this rammed earth wall in the middle of the building as a part of the concept. And then when it came to later to the cost calculation, the clients asked, well, reinforced concrete is much cheaper. Can't we do it just in concrete? And then the architects used the calculation of the embodied impact and tried to assess different variants. So on the right, we see variant 0, what we call the conventional concrete wall with a concrete slab and a floor, and then instead having a rammed earth wall. And we see there's a big drop in the embodied carbon. Then they had some other ideas how to save carbon instead of using an earthen floor, for example, or using only a strip foundation instead of a base plate, which would be cheaper. And you can see some small savings, but finally the clients were convinced to go for this rammed earth wall, but then for the cheapest solution. So the aim is here always to have the outcome of this life cycle assessment, in this case mostly the embodied carbon, as a criteria to take decisions in the design process, of course combined with other criteria. So what can we expect in the future? Or at least in the national law, it looks like this, that currently or from next year on there's no limit value, but then slowly the limit values will be introduced and tightened throughout the next years, always with the goal, also as Pierre said, to go towards zero greenhouse gas emissions in the year 2045. I think this will hopefully have a big impact, and all over Europe, I think we can soon expect a mandatory LCA in some form, so with different system boundaries or different assumptions, but in a way a simplified LCA for all buildings. And this will also cause a higher demand for environmental product declaration, which then makes it easier for the people to calculate the LCA specific for their material. And we also have been seen, especially in the last year, that more and more architect offices or the bigger energy engineering and consultancy office develop their own little plugins for their BIM tools to try to integrate this data into the design process. Now I want to ask, does this really lead to better buildings? And there I just want to also point out in a way the limits of the LCA method. So we can use LCA to answer the question, what's the most environmentally friendly option to provide a certain function? As such, it's a measure of efficiency, and that's fine. And we can compare also different functions, or in the way, for example, if we want the housing, different options, how to provide this housing. What LCA cannot answer is the question, do we really need this function? So measures of sufficiency. And in a way, we see a lot of discussion of efficiency, but sometimes sufficiency is more a qualitative and a social discussion that's needed. So here, the method in itself is limited. Still think it's an important step towards better buildings. And that's one study I did during my PhD, where I gave students a LCA tool, and one group used the tool in the design of a student housing project, and another group didn't have access to the tool. And I compared the outcomes at the end. And on average, the group that used the tool, their buildings had 30% lower greenhouse gas emissions. And there were a lot of problems in using these tools, and I'm sure that most of the results were completely wrong. But using the tool forced the students to think about their material selection, and only by this already, I think they take better decisions. So I think there's a really big chance of using LCA as to focus on which materials to pick. Thank you very much, and I think there's maybe 1 minute left for questions, but otherwise we'll have a discussion later.
Yes, thank you very much, Alexander. I haven't seen any questions coming in, so maybe we leave it at this point, and we will wait for the discussion round later on to address any potential questions.